Okay, so looking at quadratic functions today. A quadratic function is any function of the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a is not 0. The graph of a quadratic function is called a parabola. The parent of all quadratic functions is f of x equals x squared. So 0, 0, that point where the graph of x squared turns around, is called the vertex of x squared. So if I was going to graph 2 times x minus 1 squared minus 3 via transformations, what transformations are going to take place? What does this 2 out front tell me is going to happen? Vertical stretch, and then this minus 1, right 1, and then the minus 3, down 3. So let's list several key points on x squared, and then we'll do those transformations and see what we get. Okay, so 0, 0 is kind of the most key point, right? And then if the points on x squared would be 1 and 1, 2, 4, and then maybe we'll do negative 1, 1, and negative 2, 4. So those are just a few points on x squared. If you wanted to be more accurate, you could just pick a few more points, but for brevity, we'll just do these. Okay, so let's determine where each of these points go when we transform. 0, 0. First, I'm going to do a vertical stretch by a factor of 2, so that means double the y-coordinate, right? So if I double the y-coordinate of 0, 0, I'm still at 0, 0, right? Then if I move right 1 unit, how does this coordinate change? Goes to 1, 0. And then I go down 3, so I would land at 1, negative 3. So I'm going to go through this for each of my points. So let's do 1, 1. Okay, 1, 1. When I double the y-coordinate, I would become 1, 2. Double the y, yep. And then I go right 1, so I'm going to land at 2, 2. And then I go down 3, so I would be at 2, negative 1. And I'll do 2, 4, and then I'll stop there because the other two are mirror images. So I'll do 2, 4, double the y-coordinate, and I'm going to be 2, 8. Right 1, 3, 8. And then down 3, 3, 5. So new points are now 1, negative 3, 2, negative 1, and 3, 5. And that's going to be the right half of my parabola, something like that. And then the left half is just the mirror image, so something like that. So where did the vertex of the parent function land? It started at 0, 0, and it moved to 1, negative 3. Okay. Could you have identified 1, negative 3 just by looking at this formula? Yeah, sort of. We get a 1 there, negative 3 there. Yep. So this thing, when you write a parabola, when you write a quadratic function in that form, we call it the standard form. Sometimes you call it the vertex form. You have some number out front. In our case, it was a 2, right? Then x minus h squared plus k. So h comma k ends up being the vertex. Okay? The vertex always lands at h comma k, and a represents a vertical stretch. So this is vertical, well, stretch or shrink depending on the value of a. By a factor of a, and then right h, up k. So the standard form is convenient because it immediately identifies the vertex of the parabola as h comma k. And when a is positive, how does that affect the graph of the parabola if a is positive versus negative? The direction. Yeah, when a is positive, it'll open up, just like x squared does. But when a is negative, you reflect over the x-axis, and the parabola is going to open down. When a is a small number, the parabola opens more flatly than when a is large. When you're trying to sketch the graph of a quadratic, once you know the vertex and whether it opens up or down, it can be helpful to find the x and y intercepts. Switch colors, that green is difficult to see. All right, so let's sketch the graph of this quadratic function, negative x minus 1 squared plus 4. So what are my values of a, h, and k? A is negative 1, h is 1. Yeah, because the minus is part of the formula, so it's just the number after that. So it's a 1, and k is 4. Yeah. Okay, so what's the vertex of this parabola? 1, 4. Does it open up or down? Down. And then let's find the y-intercept and the x-intercepts, because that will help us finish the graph. So finding y-intercepts and x-intercepts is something you need to be able to do on this upcoming test. So this is good practice. So to find a y-intercept in general, what do you do? Plug in 0 for x. Yeah, plug in 0 for x. So I do f of 0, and that would be negative 1 plus 4, which is 3. So 0 comma 3 is my y-intercept. Yeah. And then for x-intercepts, in general, make y 0. So you set it equal to 0. I'm going to replace the f of x with a y with a 0, and I get negative x minus 1 squared plus 4. So to solve that, I could multiply it all out and use the quadratic formula, or I could use a little trick that we learned a while back. I'm going to add this x minus 1 squared to both sides. And now I have something squared equals something squared, so I could square root both sides. So the square root of something squared is the something. Square root of 4 is plus or minus 2. Add 1 to both sides. So positive 2 plus 1 is 3. Negative 2 plus 1 is negative 1. And you don't have to use that method if you're more comfortable multiplying it out and factoring or using the quadratic formula, that's fine. Do what on your calculator? Like graphically? Not on a test because you won't have a graphing calculator. But in general, yeah. Yes. Y is 0, right? Oh, okay. Yeah, so that means the coordinates of my x-intercepts are 3, 0, and negative 1, 0. Yeah. All right, so now I have all this information about my parabola. Let's use it to draw the graph. So I know the vertex is at 1, 4. And I know it opens down. My y-intercept is at 0, 3. And my x-intercepts are at 3 and negative 1. So my graph is going to look something like this. Okay, so same function, negative x minus 1 squared plus 4. I now have graphed it. I just want to change it from standard form into the form ax squared plus bx plus c. So to do that, you just do the multiplication. So this is going to be f of x equals negative. When I do x minus 1 squared, I get x squared minus 2x plus 1. So I'm just doing one step at a time here. I'm just going to square the x minus 1. I'm going to distribute this negative. So I have negative x squared plus 2x minus 1 and the plus 4. And then combine my like terms here, and I have negative x squared plus 2x plus 3. So I've made this look like ax squared plus bx plus c. You just multiply it all out. This form is handy because you can immediately see the y-intercept. Right? The y-intercept was at 3. When I plug the x's in, you always get the constant. So that form is good for seeing the y-intercept versus the standard form, which is good for seeing the vertex. Okay, so it's pretty easy to go from the standard form to the ax squared plus bx plus c form. You just multiply it out. Going the other way is a little bit trickier. So to change from ax squared plus bx plus c back to standard form, the a in both forms is the same. So you immediately know a, right? It's the same. And then you just need to identify h and k, and you'll have everything you need to be in standard form. So the vertex of a parabola that's given in this ax squared plus bx plus c form, the x-coordinate of the vertex is negative b over 2a. That's your h. Right? And then take that negative b over 2a, plug it into your function f, and that'll get you your k. And I haven't derived this for you. I haven't explained where it comes from. But what is that? What does negative b over 2a kind of remind you of? The quadratic formula. It comes from the quadratic formula. Yeah. So I'm not going to derive it for you, but you can just know that that it does come from somewhere. Okay, negative x squared plus 4x plus 1. I'm going to change it to standard form, and then I'm going to graph it. Okay, so what is the vertex of the parabola? So you can't read it right out of the equation, but we can calculate it by saying, well, h is always negative b over 2a. So b in this equation is a 4. So this is negative 4 over 2 times negative 1, which is 2. And then k is the y-coordinate associated with this x-coordinate of 2. So I can figure that out by taking that 2 and plugging into f. Right? So k is f of 2. So when I plug a 2 in here, I get negative 4 plus 8 is 4 plus 1 is 5. Into f, yes. We have a formula for h, it's negative b over 2a. Then whatever you get for that, you plug that into f, because that will give you the y-coordinate when the x-coordinate is 2, which is exactly what we're looking for. The y-coordinate of the vertex. Yep, and f is the original was given. Yep. So the vertex is 2, 5. So I could plot that. 2, 5 is the vertex. And then if I want to put this in standard form, right? Standard form was a times x minus h squared plus k. So what is a in this case? Negative 1, because the a in this form and the a in this form are the same. So I have a negative 1. And then my h is 2, so I have minus 2 squared plus k, which is 5. So there's my standard form. Does this parabola open up or down? Down, because the a is negative. To find the y-intercept of the parabola, y-intercepts, plug in 0 for x. So I calculate f of 0. I can use this one or this one. They're equivalent, right? This formula or this formula here are equivalent. So I can plug a 0 into either one, and I'll get 1. So my y-intercept is 1. And then my x-intercepts I get by setting either equation equal to 0. So if I used this one, I'd have 0 is equal to negative x squared plus 4x plus 1, and I could factor or use the quadratic formula. Let's use the quadratic formula real fast. Okay, so I've got negative b, which is negative 4. Actually, put parentheses around the whole thing. Negative 4. We'll do plus first. It's plus or minus. We'll do the plus first. Plus the square root of b squared minus 4 times a times c all over 2 times a. And I get negative 0.24. Okay, so that's what I get when I do negative b plus the square root of b squared minus 4ac all over 2a. And then I'm going to do this all again, but I'm going to change that plus to a minus. And I get 4.24. So now to graph this thing, I've already got the vertex, I've got the y-intercept, my x-intercepts are at negative 0.24, like right there, and 4.24 right there. Yeah. Let's see, if I plug a 2 into here, I get negative 2 squared plus 4 times 2 plus 1. 2 squared is 4, but there's a negative in front, so it's negative 4. Negative 4 plus 8 is positive 4 plus 1 is 5. I think you're confusing negative x squared with negative x squared. That negative is not glued to the x, because the order of operations says raise that to the power, then multiply by negative 1, exponents before multiplication. When you write it like this, it says do the multiplication, then square it, because the parentheses come first. The x-intercepts? Yeah, okay. So let's see, if I had said negative x minus 2 squared plus 5, set that equal to 0, I would add the squared term to the other side. I would take the square root of both sides. So I would have x minus 2 equals plus or minus the square root of 5. And then I'd add 2 to both sides. And when you type that in your calculator, you should get negative 0.24 and 4.24 approximately. Okay, so far we've been given an equation in 2 different forms. I can give it to you in standard form or the ax squared plus bx plus c form, and you can draw its graph, right? So that's what we've done so far. Given an equation, draw its graph, 2 different forms of an equation. But can we go backwards? If we give you the graph, can we come up with an equation? So I want to find an equation. I want to find both forms for this parabola. So the vertex of this thing, I don't know if that's hard to see on your paper. I believe that says 3, 6. 3, 5, okay. 3, 5, and then this point was 6, 23, and this point is 0, 23. Okay, so for vertex form, I have the vertex, I know what it is, so the vertex form is going to be the easiest one to use. So f of x is going to be a times x minus h squared plus k, and I immediately know h and k off the bat because I was given the vertex. So I plug them in. So I have a times x minus 3 squared plus 5. And then my only question is, what is a? How could I figure out the one missing variable? Yes, a has to do with whether it's opening up or down. So because that parabola is opening up, what do I know about a? It's positive. It's a positive number. But what positive number is it? How do you know? Oh, no. No, that 5 tells you the k. It tells you nothing about the a. Yeah. I don't know if it's 5. I don't remember. So this is very similar to when you find the equation of a line and the thing you don't know is b, right? What you have the slope, and so you say, okay, y equals 3x plus b. How do you find that b? You're right here, and you need to know what that b is. Nobody remembers how to do it? Solve for it using what? I need to put something in for x and y so that b is the only unknown. What do you put in for the x and the y? A what? Values from the graph. A point on the graph. Not the vertex, because we already used the vertex. Any other point on the graph. So at this point, when you're finding the equation of a line, you plug in a point and solve for b. Right? You plug in a point and solve for b. That's what we do here. Pick any point you want, plug it in for x, the x coordinate for x, the y coordinate for y, and you solve for a. So I'm going to use 0, 0, 23, because zeros are easy to work with. Right? So I'm going to put 23 in for y. A, I don't know. I'm going to put in 0 for x. And now I have an equation with just a single unknown a, and I can solve for a. So negative 3 squared is 9. So I have 9a plus 5 equals 23. And I get a equals 2. And it did come out positive, which we were expecting because the parabola opens up. So my final version of the formula is going to be f of x is equal to 2 times x minus 3 squared plus 5. All right, so I went from here to here, plugging in a 2 for a. All right, and then how do I get the ax squared plus bx plus c form? Just do it out, multiply it out. So this is going to be 2, square the x minus 3, and I get x squared minus 6x plus 9 plus 5. And then distribute the 2 and combine like terms. So I have 2x squared minus 12x plus 18 plus 5, which is plus 23. And that matches 23 is always the y-intercept. The constant term is always the y-intercept. Okay, what key feature of a quadratic function marks its maximum or minimum? The vertex. So if you're ever asked about the maximum or minimum value of a quadratic, you know they're just asking you to find the vertex. No, today's stuff's not on the test. Questions? Okay, so if I have this quadratic function, 4x squared minus 16x plus 1,000, without graphing it, without coming up with its vertex, does this function have a minimum value or a maximum value? A minimum, how'd you know that so fast? The a value is positive, which means it opens up, which means its vertex represents a minimum value. So let's find that minimum value and determine where it occurs. That is just find the vertex. That's all it's asking you to do, is find the vertex. So remember, the x-coordinate of the vertex, we call it h, is at negative b over 2a. And that would be 16 over 2 times 4, which is 2. And then to get the y-coordinate, right, if you know the x and you want to know the y, you can just plug into the function, right? So k is just f of 2. If I plug a 2 in there, let's see, 2 squared is 4. 4 times 4 is 16 minus 32 plus 1,000. So that's negative 32 plus 1,000. It's going to be 968. Oh, negative 16, right? Not negative 16, not negative 32. So that's going to be 984. So this is the minimum value, and this is its location. Right? So you have a minimum value of 984. It happens when x equals 2. What's the domain of any quadratic function? Negative infinity to infinity. Because there are no restrictions on a quadratic. You can square anything, any old thing, right? What's the range of this function? What is its smallest y value? No. 984. 2 is an x value, right? 984 is the minimum y value. So that's the first value in the range, and then it goes up to infinity because it opens up. All right, I think I've been talking too much. Maybe you should try one. Okay, so an archer's arrow follows a parabolic path. Parabolic is the word for the shape of a parabola, right? And the height of the arrow is modeled by this function, and x represents the horizontal distance. So if you know how far horizontally it's traveled, you can figure out its height above the ground. So it's always good to remember, right? X is horizontal distance, and f of x, or y, right, is vertical distance above the ground. So sometimes it helps to jot those things down to keep track of what things mean in a real problem. So I want to know the maximum height of the arrow. So I'm looking for a y coordinate because it's a vertical height, right? And how far from its release does it occur? So that's the x value. So maximum of a parabola always happens at the vertex, right? A maximum or a minimum will always happen at the vertex. We know this guy has a maximum because the a value is negative, so it opens down. Okay, so and this happens at negative b over 2a. So I've got -2 over 2 times -0.005, and that is 200. So 200 feet horizontally, once the arrow has traveled 200 feet horizontally, it's at its maximum height. And to figure out what that maximum height is, plug 200 into the original function. That'll give you the y-coordinate when the x-coordinate is 200. So who's done it? 205. Okay, so this is your max height, 205 feet. And 200 is the horizontal distance the arrow has traveled when it hits that maximum height. Okay, and then part B is find the distance the arrow travels before it hits the ground, right? So when it hits the ground, what is its vertical distance above the ground? 0. Yeah. And f of x represents vertical distance, so I'm just going to replace my f of x with a 0. Right, because my vertical distance is now 0 because the arrow is on the ground, and I'm going to solve for x, the horizontal distance that the arrow has traveled. Anybody solve it? X is 29 point something. 289.8. Okay. 289.8 feet. All right, why did you only give me one answer when a quadratic always has 2? The other one's negative, and you can say, well, the arrow can't go backwards, so this is the only viable solution. Yeah. For it to hit the ground? Well, according to our formula, it hit the ground after 289 feet. Is that wrong? All right, let's do it out. Yeah, it seems like it's got to be 400 because the horizontal distance when it hits the maximum is 200, and parabolas are symmetric. So let's see, if I use the quadratic formula, let's see what I get. Okay, so I have -b plus the square root of b squared minus 4 times a times c all over 2 times a. Oops. Okay, that one's negative. And so I'll do the -b minus 402.48. No. Oh, that could be. Yeah, don't do that. Don't round until the very end. Why is this 402 and not 400? Any guesses? Yeah, he's a certain distance tall, so the arrow doesn't start on the ground, right? If you followed the parabola backwards behind the archer, it would probably hit the ground 2 feet behind him. So that's why. All right, one more example together, and then I have some more for you to try. All right, so we have a farmer has 400 feet of fencing. He went down to the farmer's exchange, about 400 feet of fencing. He wants to build a rectangular corral. Right, so, and to save money on fencing, he's going to use the bank of a river as one boundary, right? Because his cows can't swim, so they won't get past the river. So we've got a river, right? That's a boundary, and then he's going to build a fence on three more sides to create a rectangular corral. And we want to find the dimensions that would enclose the largest area. So let's say these guys are x, comes x feet out from the river. How many feet would he have to build the horizontal part? 400 minus what he's already used, right? So this would be 400 minus 2x. So I want to enclose the largest area, right? What is the area of this corral that I just built? X times 400 minus 2x. If you distribute that x, you would get negative 2x squared plus 400x. That's a quadratic function. Can you find the maximum, right? Does this have a maximum or a minimum? Maximum. It opens down, which means it has a maximum point, right? So the max point, right, is the vertex. So if I want to find the vertex of this thing, we're at negative b over 2a. So that's 100. And then k, the y-coordinate, is what you get if you plug that 100 into the area formula. Right. So 100 squared is 10,000. So that's negative 20,000 plus 40,000 is 20,000. That was a of 100. So what are the dimensions that would give maximum area? How does all that work? Answer the questions. What by what gives maximum area? 100, right? Because we solved for x and we got 100. Right? That's my h. My h is an x coordinate. And a of 100, that's an area, right? So 20,000 is not one of my dimensions, it's the area, right? And then, so to get the other dimension, this length right here, 400 minus 2 times x, and x is 100. So 400 minus 200 is 200. So those are the dimensions that give maximum area, 100 by 200. And 100 times 200 is 20,000. That's the maximum area that I got using my function.